Hi everybody, welcome back to class. In today's class, we are going to continue our discussion about mobile games, which is our topic for Unit 3. Last class, we started a new topic about mobile games, which was sprites. And in class, we talked about what sprites are and created the sprite practice app. And for homework, you should have begun working on the collector game. In today's class, we are going to continue talking about sprites. We'll go over a little bit review of some of the things we spoke about last class, as well as introduce some new blocks that have to do with sprites and sprite types in Thunkable. And then we are also going to review for each loops. We discussed for each loops in Unit 2, and we use it for the Addition app and the Note Taker app. But in this class, we're going to talk about how we can use for each loops with sprites. And then once we finish talking about that, we will create our in-class app, which is called the Clicker Game. And after the Clicker Game, for homework, you will complete the Whack-A-Mole / Spooky Smash game, which has a lot of the similar aspects of the Clicker Game, but with some more fun added elements. So let's get started. Last class, as I said, we spoke about sprites, and we talked about how sprites are images that are placed on the stage, which are inside of the canvas on our Thunkable app. But sprites are different than most images that we've used so far in class. We've used images in our apps with the image component or as background images on buttons or on screens, but sprites are different than those images because they're much more interactive. Sprites can be touched or dragged across a screen. They can collide with other sprites or collide with the edge of the screen or have animation to them, and in general just have a lot more dynamic interaction from the user. Sprites can often be seen as like the characters or avatars or even objects that are interactive in your games. And sprites refer to each individual instance of a particular character or object or avatar in your game. But along with this discussion of sprites, we also have something called sprite types. Every sprite in Thunkable has a type, and a sprite type are categories of sprites that you can add to your app. And sprites that all belong to the same type have similar or exactly the same characteristics. So things like their size, the image that they use, their animation, the movement, what happens when a certain kind of sprite interacts with them, are all going to be similar among sprites that are of the same type. In this way, sprite types are sort of like a blueprint that you can create and then use to make individual sprites. And the reason why we use sprite types is because it makes it a lot less tedious to create new sprites when we know that we're going to have multiple sprites that belong to the same type, or that behave or look in a similar or exactly the same way. So we can define a sprite type, give it all of its properties and characteristics, and then easily create multiples of that sprite type, and we know that they will all look and behave in the same way. Last class, we also started exploring some of the new block drawers that we get when we add a canvas to our Thunkable app. But one of the drawers we had yet to explore was this drawer called Add and Remove. This drawer only has 3 different blocks in it, and only one of which we're actually going to use in class today and for your homework app. But since there's only 3 in this drawer, I thought I'd just point all of them out to you in case you want to use them maybe for your final project if you decide to create a game. So first up in this drawer is this block that says create, and then it has the name of a sprite type, and it has an X and Y coordinates. So what this block allows you to do is dynamically create new sprites that belong to a certain type while your user is using your app or playing your game. Last class, we talked about how you can create new sprite types and new individual sprites in the Canvas tab in the Sprite class panel. You can click on that blue button that says Add Sprite Type and drag new sprites onto the stage. But similar to how we've learned with the design side, that is something that will occur as soon as the app initializes. Any sprites or sprite types that you create in the Canvas tab in Thunkable will be present and visible in your app as soon as the app opens. But maybe you want to be able to only create some sprites as certain things happen in your game. Maybe if your user goes to a new level or creates some sort of achievement or does something of that nature, and you want to create a sprite or have some sort of sprite appear as a result of that action, then you can use this block to create sprites that belong to a type and then place them in particular X and Y coordinates and have them move as you see fit. The second block here says remove and has a drop down where you can select a particular sprite. This block will have you have a sprite permanently removed from your game. Last class we touched on the hide and show blocks, which I'm actually going to look at again in a second here. Hiding and showing is a temporary, like visible and invisible of a sprite, whereas this new block, remove, will permanently remove a sprite from the game, and it cannot be brought back unless you reinitialize the game. Last but certainly not least, here is this block called all sprites in, and then lists a sprite type. In this example app, I have this sprite type called elephants because I have multiple sprites that look like elephants, which we're going to use in the clicker game in a second here. But what this is a block that we will use today and you will use in your homework app. And essentially what this block does is it gets you a list of all the sprites that belong to a certain type. So let's say I have 3 individual elephant sprites in this game, elephant 1, elephant 2, elephant 3. Maybe I want to do something similar to all the sprites that are elephants. Then I can use this block to get a list of all those sprites that belong to the type elephants. And this is exactly, we talked about list extensively in Unit 2. This is the same sort of idea, except for instead of having a list of text or images or sound files, now we can have a list of sprites. And all those sprites will belong to the same type. Okay. Moving on, we touched on the looks drawer last class. We know that the blocks in the looks drawer have to do with how sprites or sprite types visually appear on the screen. And we actually spoke about all of these last class, but I just wanted to give you a quick refresher on them because I know it's been it's been almost a week since we talked about it. So these first 2 blocks here, the hide and the show, these 2 blocks will allow us to make a sprite visible or invisible from the screen. So hide will make them invisible, and show will make them visible. Unlike the remove block that we just spoke about, hide and show is temporary. So you can hide and show a sprite as much as you would like, and it's not going to disappear from your app. It's just going to visually not be shown. Whereas the remove block physically removes or permanently removes it from your app. I actually didn't touch on this block last class, which is the third one here, which is visible. This block is the getter for these hide and show blocks, and this will tell us if a particular sprite is currently hidden or shown. And then skipping down to the bottom here, we have another block that we are familiar with from last class, which is the flip to the left, to the right, upside down, or right side up block. And that block allows us to flip a sprite's image in all these 4 different directions in order to give it a little bit of animation. We also touched on some new event handlers last class. Most of these we already have touched on except for one, which is the one I'm going to more extensively speak about, but I want to just give you a quick reminder on all 4 of these. So the very first event handler that we get in this events drawer is when canvas loads. This when canvas loads event handler is very similar to the when screen opens block, but instead it occurs when the canvas loads, which usually happens, like a half a second or so after the screen itself opens. One thing to note about the when canvas loads block is when you would want to use this block over when screen opens. And the rule of thumb is you want to use the when canvas loads block when you're trying to initialize something about objects that are on the canvas or on the stage, which will always be sprites or like the canvas's label. The reason for that is that the screen will load quicker than the canvas, and depending on how many items, how many sprites you have on the canvas, it might take an extra second or so for the canvas to load, So if you try to say move a sprite in the when screen opens event handler, you might run into an error because the sprite might not have loaded yet at that point when the screen first opens. And so you might get some sort of error or things just won't occur the way you want them to. And so if you're trying to move a sprite or change a canvas label or anything that you need to initialize about your app that has to do with objects or items that are on the canvas or the stage, you should put those blocks inside the when canvas loads event handler. Another thing to note about this event handler is that this event handler will only occur once in the usage of your app. So the way that the canvas works is once we go to the screen that has the canvas on it, the canvas will load. And then if we navigate away from that screen to, let's say, a game over screen or maybe like a leaderboard screen or something of that nature, and then we want to go back to the screen where the canvas is, the canvas will have already been loaded. It's already loaded in the background. All you're doing is navigating back to that screen. So the blocks inside of this event handler will not execute again if you navigate back to the screen. So there's a little bit of a give and take here because sometimes you want to maybe reset the game so your player can play the game again. But the blocks inside of this event handler will only occur the first time that your user plays the game, not any time after that. So that's an important thing to note about this event handler. Last class we also talked about this third and fourth event handlers, which is when a certain sprite or sprite type collides with another sprite or sprite type, and then the fourth one, which is when a sprite or sprite type collides with an edge of the stage. These two event handlers occur when a sprite or sprite type collides either with another sprite or with a particular edge of the stage. You can choose which particular sprite or a whole type of sprites is included in this event handler, and you can also choose if you want something to occur when a sprite collides with any edge of the stage, or just choose a particular top, bottom, left, or right edge. Last but certainly not least is our new event handler that we haven't gotten to use yet, which is the second one here, which says when a sprite or sprite type is clicked. This event handler will occur when the chosen sprite or sprite type is touched on your screen. And you can see over here on the right hand side, when you pull this block out of the drawer, you get another one of those little green local variable blocks that we spoke about for the two collides with event handlers. For the when clicked event handler, this green component local variable block will be representative of which particular sprite was clicked on. So if you choose an entire sprite type, like I have with this block, I've chosen this sprite type called elephants, and I have multiple elephant sprites in this app, like elephant 1, 2, 3. I want the same thing to happen no matter which elephant is clicked on, but if I only want to affect the one sprite that was clicked on, like let's say I click on elephant 2, then this component will tell me that it was elephant 2 that was clicked on. And so I can say like move elephant 2 or show or hide elephant 2 and not have all the other elephants affected. Okay. So that was mostly some review of some of the blocks that we learned last class that we're going to utilize again in our in-class app and you'll use in your homework app. And the other thing I wanted to go over a quick review on is for each loops. Like I mentioned, we talked about for each loops in Unit 2 with all of our foundational programming concepts. And I know that you guys love for each loops. But as a quick refresher, for each loop is a sort of loop and thunkable. In computer science in general, there are a lot of different kinds of loops. In this class, we're only going to talk about this particular kind of loop, which is a for each loop. But in general, loops are a tool that you use in programming when you need a particular line of code or several lines of code, or for us, several blocks of code to repeat over and over again in some capacity. What makes for each loop special is that for each loops determine how many times that code is repeated based on how many items are in a list. So For each loops are what are called condition controlled loops, which means that they have a set amount of iterations, and an iteration being how many times that code is repeated. And that's determined again by the length of the list that they iterate over. So when you use a for each loop, the code inside of the for each loop will execute once for every item in the list, once for each item in a particular list. So we can find the block for a for each loop in the control drawer, and it's this one that says for each item J in list, and we have to attach to the end where this open space is a list. And essentially what will happen is we will select, when we iterate over this list, we will select each item in that list one at a time, and then can do something with each of those items. So the way we'll use a for each loop for this unit is by iterating over lists of sprites. So you remember from the very beginning of the slideshow, we were introduced to this new block in the add and remove drawer, which is all sprites in, and you choose a sprite type. This block again will give you a list of all the sprites belonging to a particular type. And so we will use this block in conjunction with the for each loop block in order to iterate through all of the sprites that belong to a particular type. So let's say I want to be able to move or show or hide every sprite of a particular type. Then I can use a for each loop, so I don't have to tediously go through and say move elephant 1, move elephant 2, move elephant 3, and do the same thing for every sprite and have all that repeated code. Instead, I can just iterate through this list and have the action I want to do with each of those individual sprites defined within my for each loop. So in this example here, I have a for each loop that says for each item elephant in list, and then the list that I have added on here is all sprites in elephants. So this for each loop is going to iterate through each individual elephant sprite that is of the type elephants. And this singular elephant here that's in the yellow block is, remember, a local variable that will be representative of each individual elephant sprite one at a time. So in the first iteration of this loop, that local variable elephant will be equal to the first elephant sprite, elephant 1, let's say. And then the second iteration of this loop, that local variable elephant will be equal to the second elephant in the list, let's say elephant 2, and so on and so forth until we reach the end of the list and we've gone through all of the sprites that are of the type elephants. So building on that example, I have some more code here. So I added inside of this for each loop 2 blocks. I have show elephant and move elephant to the x and y coordinates 100, 100. So in this complete for each loop, what's going to happen is the for each loop will iterate through each individual elephant sprite, so all the sprites that belong to the type elephants, and will show that sprite and then move that sprite to the xy coordinates 100, 100. And it'll do that one at a time for each elephant in this list of all sprites in elephants. Remember, you can also rename that local variable, which is what I'm showing you in the bottom screenshot here. If you click on the drop down, it'll bring up this menu where you can click on rename variable. By default, it's the default is the letter J, but you can rename it to something a little bit more that makes a little bit more sense for your app. So in my example, I renamed it to the singular elephant because it's going to represent each individual elephant sprite one at a time. Okay, and that is what I wanted to speak to you about today. So let's get started working on our in-class app, which is called the Clicker Game. So you can find all of the information about the Clicker Game on Canvas under today's date, which is Monday, October 31st. And as always, I have a little video here that shows you how the game works, as well as I've written out all the functionality, and I also have a link down here to the example of the completed app so you can see what this app is meant to do. But as I've mentioned, it doesn't always work super well in this preview, so that's why I've given you the video, and I'm just going to show you on my phone what it looks like actually. So let me show you that. So over here on the left-hand side, I have my phone, which shows you what the clicker game is all about. So in the very top here, we have a label that says score 0, and then in the middle of the screen, I have a canvas. It's denoted with the light gray background, and on my canvas, I have 6 sprites. I have 3 sprites that are elephants and 3 sprites that are mice. And at the very bottom here, I have a single button that says reset. So the point of this game is you have 2 different kinds of sprites. Sprites that are good, that will increase your score, and sprites that are bad and will decrease your score. And so when I click on a good sprite, which for me are the elephants, that sprite will disappear, and my score increases by 1. And so if I click on each elephant sprite, it will disappear, and my score goes up by 1 until they've all disappeared. On the other hand, if I click on a mouse, which are, for me, the bad sprites, they will also disappear, but it will decrease my score by 1. And so if I click on all the mice, I'm now clicked on all the sprites. They're all hidden, and my score is back to 0. So once I've done that, then I can click the reset button, and all of my sprites will reappear on the canvas, and I can play this game over again. One thing that you'll notice about this is every time I click reset, all the sprites move to random locations within the canvas, random XY coordinates, and that's true from the very beginning of the app. So at the very top, when the app first opens, all the sprites are again placed in random XY coordinates that are within the stage, and they never go off the stage. No matter how many times I click on reset, I should always see all 6 sprites within the stage. So that's the app that we are going to build today, and let's get started doing it. So I'm going to hop over to Thunkable and create a new app. I'm going to call it Clicker Game. Select category, and hit create. Okay, so I need a couple components for this app. The first is I need a label for my score, so I'm going to add a label. I need a canvas where I'll put all of my sprites. Remember, you can find the canvas in the user interface section with the easel icon. And then lastly, I need a button for the reset button. Great. I'm just going to go through and reorder these items so the label is on top, canvas in the middle, and the button on the bottom. I'm going to go ahead and start renaming some of these components. For my label, I'm going to call it the score label. And you can see in my example app that when I first open up the game, the score label's text is initialized, say score : (0). So that's when I type in the text property. I'm going to skip down to the button. I'm going to call this button the reset button. I'm going to set its text to say the word reset, and then I'll just do my styling here. I made the font size a little smaller, the background color black, and I also took away those rounded corners by going down to the border property and changing its border radius to 0 to make it have sharp edges. Now, last but certainly not least is the canvas. If we preview this app, you'll see that the canvas by default has this white background. It's kind of hard to tell where the the stage begins and ends. So I'm going to give the stage a little bit of a background color so I can see where it begins and ends. You can do that by clicking on the stage in the app tree and then its first property is background color. So I'm going to give it a sort of like light gray color just to distinguish where it begins and ends. And then in my example app, I have a bit of a border around the canvas so that there's some white space. You can do that just by resizing your canvas and stage a bit. I find that the best way to size the canvas and the stage, because the stage is inside of the canvas, is to try to just size them exactly the same. For the stage, you actually can only select absolute height and width. It only gives you that option. So I'm going to actually make my stage just a tiny bit smaller than what the default is, so I have a little bit of space. And then I'm actually going to hop over to my canvas and change its height and width to be absolute and have it match what my stage's height and width were. So my stage is 400 high and 350 wide. So I'm going to do the same for my canvas. So I'm going to choose absolute, do 400 high and 350 wide. And now I should end up with something where I don't really have that scroll bar. I mean, it's there a little bit, but for the most part, they are, both the stage and the canvas are sized exactly the same. I'm actually going to make mine a little bit taller, maybe. I still want it to be a little bit taller, actually. There we go. I'm happy with that. Last thing I'm going to do on this design side is just add a little bit of margin to the top and bottom of the canvas so that the label and the button aren't right up against the edge. So right now I'm selected on the canvas component. So scroll down a little bit to the margin section and add maybe like 20 pixels of margin to the top and the bottom, just to give a little bit of space between all these elements. Great. So now let's talk about our sprites. In my example, or in the assignment on Canvas, I say that you have to have at least 2 different sprite types, right? We're going to have one type of sprite that are like the good sprites that give you points, and then another type of sprites that are the bad sprites that take away points. I do want you to use your own images, not just the default Thunkable Beavers. I gave you the elephant and mouse images that I use in my example app here if you want to use those, but you're welcome to use whatever images you see fit. I'm just going to go ahead and use this elephant and the mouse images. And so I'm just going to right click and save these images to my desktop so that I can find them easily. And then over on Thunkable, I'm going to go ahead and just upload those files in the file section of the app tree. Great. So by default, when you add a canvas to your Thunkable app, you get one sprite type and a sprite that belongs to that sprite type. We'll go ahead and make this first sprite type one of our 2 sprite types. So if you're going to do this on the Canvas tab. If you don't see the Canvas tab appearing, just click on the stage or the canvas, and the Canvas tab should, in the app tree, and the Canvas tab should appear for you. So I'm going to select on one of my sprite types, sprite type 1. I'm going to go ahead and change the picture for this sprite type. So I'm going to click on this empty box. I'm going to choose, let's say, my elephant image, and then click add, and then that will give me my little elephant image. And then I can actually delete the old little red beaver by hovering over that picture and clicking the X next to it. And I also have one sprite that belongs to that type. So in order to, I need not just one of this sprite type, I actually need 3 of them. So in order to add 2 more elephants, I'm going to go over to the sprite class panel and click and drag 2 more of those sprites onto my stage. I also want to rename these sprites so that I can keep track of them better. For some reason my panel isn't showing up, so I'm just gonna refresh real quick. There we go. So I'm gonna change the sprite type name to elephant sprite type so that I know that that's the type. And I'm just gonna rename my elephant sprites to elephant 1, elephant 2, and elephant 3. Great. Now I need a second sprite type for my mice. So I'm going to click on the Add Sprite Type button. I'm going to rename this one to Mice Sprite Type. I'm going to select my mouse image, click Add, and now I have my mouse image, and I'm going to delete the default Thunkable Beaver. And then I need 3 of these mice. I'm going to drag 1, 2, 3 onto the screen. And you can see that as I start adding all these mouse sprites, they all look the same because they all belong to this mice sprite type. They're all going to share those same characteristics, including its picture selection. So I'm just going to go through and rename all these to mouse 1, mouse 2, and mouse 3. And that's it. That's all we need to do on the Canvas tab. So now let's move over to the Blocks tab. So in the blocks, the first thing that I want us to work on is what happens when we click on the individual sprites. So when I click on any elephant sprite, I should have that sprite disappear and then have my score increase by 1. And then similarly for the mouse sprites, if I click on a particular mouse sprite, I should see that sprite disappear and then my score should decrease by 1. So let's start with the elephants. We have an event handler for this that we just talked about, which is in the events drawer, and it's when elephant sprite type is clicked. So remember with this event handler, you can actually choose an individual sprite like elephant 1, 2, or 3, or mouse 1, 2, or 3, or you can select an entire sprite type. In this game, we want the same thing to happen no matter which elephant sprite is clicked on, right? So it doesn't matter if I click on elephant 1, 2, or 3. I always want that sprite to disappear and for my score to increase by 1. So we don't need to go through and do an event handler for each individual sprite and end up with 6 event handlers. Instead, we can make it a little bit simpler and just do 2, 1 for each sprite type. So I'm going to start with the elephant sprite type. The first thing that I need to happen when I click on this an elephant sprite is I need it to disappear. So this has to do with how the sprite appears. So we're going to go to the looks panel, and I want to hide that sprite. So I'm going to grab out this hide block. And in the drop down here, it lets me choose an individual sprite, elephant 1, 2, or 3, or mouse 1, 2, 3. But with the event handler that we've chosen, we don't actually, we want this to be able to work for no matter which elephant sprite I click on, right? So if I just left it with when elephant sprite type is clicked, hide elephant 1, it doesn't matter which elephant sprite I click on. Actually, that happened to work out when I clicked on elephant 1. It doesn't matter which sprite I click on. So if I click on this elephant, it'll always make elephant 1 disappear, which is not what I want to happen, right? So it doesn't matter which elephant I click on, it'll always make elephant 1 disappear. What I want to happen instead is I want the sprite that I clicked on to disappear, that particular elephant sprite. So the way I can know which individual sprite I clicked on is with this green component block. The green component block will tell us which